I have to go back here, and I'm going to have to show you guys here on the desktop. But what I did, oh, come on. Don't know. Oh, wrong desktop. It doesn't show you on the desktop. Okay. Come on. Well, I won't show you. What I'm doing today, ladies and gentlemen, let me write it on the iPad. So I can see it here on my. But I'm making your test for here. This here is going to be a take-home test that is going to be due. And I'll make it so you guys can see it in Canvas. Okay, I wanted to show you guys here on the video, but this is due on a Monday, May 29th, 2023. Okay, and actually, like I said, right now, for some reason, our wireless is bad, so I'm not even broadcasting. I'm recording, so I'll upload it later in my office today or whenever. Try to upload this video for you guys. But this is due on Monday, May 29th. Now, you're supposed to, since this is a take-home test, you're supposed to do it by yourself, not with tutors, not with each other. Okay. Also, what I sent you guys over the weekend, what did I send you guys? You guys remember what I sent you? Yeah, your final exam study guide. So I sent a final exam study guide. Because your final is going to be, I'll write that down. Do you guys know what your final is? I would like to show you online, but I can't. Let me double check. Dot. Yeah, I can't share with you guys this here. Math 262. Yeah, it's going to be on Tuesday, May 30th. And it's from 9:30 to 11:30 a.m. Okay, so that's when your final is going to be. So I just want to let you guys know it's next week and it's next Tuesday. So that's why I sent you guys a study guide early. And what I want to do is just use this time today to go over some what? Power series, because you're going to see power series on your final. Now, if you guys watched the lecture on Thursday, what did I do in the lecture on Thursday? I introduced to you guys power series. Is that right? Okay, good. Now, let me remind you guys. So what I want to do is use this time instead of test time, because I've had to miss a few days. If I didn't have to miss a few days, I wouldn't be doing this. But because I had to miss a few days, I wanted to use the time to go over some power series as opposed to the test. So I made your test take home. It's due Monday, 5/29/2023. It's in Canvas. I just sent that to you. It's in the assignment portion. So you turn that in like you turn it in as a batched PDF file, right? It's a batch PDF like you do your homework. So you guys should be familiar with how to turn that in, okay, as a batched PDF. Okay, anybody have any questions on that part? Yeah. No. That's a very good question. The final is a 2-hour exam and it's in class, so there's no take-home portion. That's a good question. Yep. I can give you extra time. I can have you guys start early and maybe end, or I can start. if you guys wanted to start earlier, maybe at 9, so you could get an early start. Maybe at 9 a.m. And then I can even stay here till probably noon. So you can have extra time on the day of your final. So there can be some extra time. Yep. So that can be done. Yep, those are good questions. Anybody have any other questions? Yes.
Will there be one question that will take too much time?
I think it depends on the student. You could be a student that takes an hour to do one question because that's you, and the person next to you can probably do it in maybe 5 minutes. So it depends on the student. Anybody have any other questions? All righty. Good. So remember, let me go back to what we did. Let me copy this stuff here. Where was it? Ratio and root test. We started to talk about these power series. Do you guys remember? So I introduced this information to you guys already. Power series, okay? So we gave you the definition. This is your definition of power series right up here, and it's centered around the value A. And then we want to know for what values of X, for what X, these values, do we have convergence? Okay. So we already had a good start on that. And we showed that you can converge at a point, you can converge for all X, and you can converge over an interval. But the interval of convergence can have some open endpoints or closed endpoints or a combination. So we really want to look at this interval of convergence when there is an interval. Okay, so that's kind of where we're at. We went through the first example of a power series, and we showed that by using the ratio test, we showed that that interval was absolute value of X less than 3, and then we had to look at the endpoints, because where it equals 1, that absolute value of X equals 3 is 1, it was inconclusive by the root test. So what you do is you go back and you check the endpoints, and when you check the endpoints, that's when you're going to have to look at the various series that you guys are tested on today, right? Those kind of things. So, in all honesty, that's when it's going to start to work now to see, can you do regular, I should say, series convergence or not? And that's what's going to happen now. So I wanted to introduce that so that we can now start to look at some other examples of this ratio test and go over those 3 criteria. So that's what I planned on doing today. So anyway, and like I did before, I sent you guys some links over additional examples if you wanted to see those. Did you guys ever look at those examples? Just curious. Anybody look at the additional examples? So I hope you guys find them helpful, because that's how you do things. Yes.
The examples weren't in your website, right?
Yeah, they're on the website. Yeah, they're all on my website. Yes, and there's actually 2 pages. One's the online notes transition page, and then the other one is just the video and worksheet page. They're the same for the most part. One has additional notes, one doesn't, but they're the same videos, essentially. So I just want to let you guys know I've been sending you both. But okay, so let's look at another power series example. Since this is going to be on your what? Final. Here's AN. So here, AN looks like this. Okay. And again, what do you guys think you want to use here? You want to use the what? Just like you did before. The ratio test. So this is going to be using the ratio test. And we want to find the values of x for which you have convergence because there's a variable now. Right? So what would that look like on the ratio test? You have what? Am plus 1. If I change my n term to n plus 1, right? That just changes wherever there's an n. It's now n plus 1, right? And so now, again, you take the ratio of am plus 1 to an, and that'll be n plus 1 factorial x to the n plus 1 over the n factorial x to the n. Right? So this is the ratio test. Now, remember now, what do you guys want to use here to simplify what's under the radical? You want to use what? Algebra, is that right? And the definition of factorial. So what do you replace n plus 1 factorial with, right? N plus 1 times what? N factorial. What about the algebra here? Isn't that x to the n, x to the first power? Then you have the n factorial x to the n here, right? So what happens now is you get to cancel the n factorials and the x to the n, and what you're left with is the absolute value of n plus 1 times x. Okay, so if you guys, are wondering about the algebra, b to the n plus m that I'm using is b to the n times b to the m. That's the algebra that we're using. That's beginning algebra. And then here, we always use properties of absolute values. So the absolute value of a product is product of absolute values. So now this becomes the absolute value of n plus 1 times the absolute value of x. And then, what do we use here? Do you guys know what we use here? We use the definition. The definition of an absolute value. And the definition of an absolute value, the piecewise definition, is what you guys see here. Okay, so what happens now is because what's under the radical, what's in the absolute value is a natural number, we just get rid of that absolute value sign. Okay, because it's positive, so you're using that logic here. So this is what we just found. This is what? The absolute value of the ratio. And that's what you're going to have to take the limit now of. So you say, okay, the limit of the ratio here, right, is the limit of n plus 1 absolute value of x. Now this is what you guys want to do here, okay? This portion here you can think of as a constant because the variable you're trying to take the limit is for this n here. So what you do is you take out your absolute value of x now. And then that's now going to be here, this particular limit here. All right. Okay, so is everybody okay with that? We took this out here because the limit is opposed to, it applies to the n variable. So now, ladies and gentlemen, you might say, well, what do you do with this? What does this mean here? Okay, I want you guys to kind of be careful with this. I want you to note a few things here. You can say that this limit is going to be what? Infinity. Is that true? How do you guys know that limit's infinity? Where does n plus 1 go to? That go to infinity? But you have to be careful. This assumes if x is a non-zero number, right? So if this x is a non-zero number, then you have this limit going to infinity, which means you have what? Divergence. Is that true? But what if x equals 0 now? Then the absolute value of 0 times that limit here, go back and put that absolute value here. Let's go back here. If that is 0, here's what I want to go back and note here. That you're now really looking at the limit, if I can get the highlighter. N plus 1, the absolute value is 0, n goes to infinity. What is this here? Do you guys know? Isn't this 0? So this whole thing is actually the 0 sequence. The limit of a constant is the what? Is the constant. Now that number is smaller than 1. And what does that mean by the ratio test? You guys remember? Yes, you have what? Convergence by the ratio test. This is the stuff you would have a test on today. So this is why I wanted people to study that and be familiar with that. You got convergence. That's going to be the constant sequence of 0. Okay, so you say, what does that mean in conclusion, right? So you say, what's the conclusion here? Well, remember, we're trying to find the values of x where you have convergence. Okay, so you have convergence only when x is what? When x is 0. Is that true? This is where you have convergence, when the set of values x is 0. So go back to the statement that we talked about here, right? What do we say we're going to have here? You can converge at a what? At a point. That's what we're talking about. You converge for a single value of x. Yes. Right, let me go back here. So last time we seen an example where this is valid. Is that true? We had an interval. Now we seen an example where you converge at a single value here, a. That's what I'm getting at. We're going to see now an example where the series what? Converges for all real numbers. So you guys can see an example. But you had a question. The question is, if you scroll down here. Right. Factorial. Right around. Okay, so here's kind of the question here, right? The question really is the other one. Right here, this n factorial? Well, that's related to what I'm saying here. Okay, remember what's the definition of factorial? You guys remember? Right, factorial, this is the definition. You start at n and you start counting backwards. You go to 2 times 1. And it's repeat multiplication. But if you start at n plus 1, you say, how does that work? Well, you start at n plus 1, and then you have n minus 1. You just keep counting backwards forever. So you might say, well, wait a minute. Isn't this portion the definition of n factorial? And it is. So I can write n plus 1 factorial as n plus 1 times n factorial. Now you might say, why do I want to do that? Because if I do, what do I get? The nice cancellation of factorial. And that's something that you're going to see over and over again with factorial. Because you're going to see a lot of factorial here for some of these kind of questions. Anyway. And then, where am I looking at here? Okay. It's kind of weird. All right, let me get an example here. I was trying to find one. It's odd. Okay, let's try this example then. Okay, another power series representation. Okay, the variable x. I want to know for what values of x you have convergence here, right? So here's again, what are you guys going to use again? This whole thing is going to be your what? an, negative 1 to the n, x to the 2n over 2n factorial. So this whole thing is your an. So what's the next term, an plus 1? What is that next term? You're going to have what? Replace your n with n plus 1. That's 2, n plus 1, factorial. Now, I think you probably want to do a little simplification here, right? In other words, isn't this power going to be 2n plus 2? And this will be 2n plus 2 also. Okay, so you're going to use again the what? You're going to use your ratio test. So you're going to take that limit by the ratio test. You take the absolute value an plus 1 over an. So remember what I do whenever I have a fraction to save some time here, right? What do you want to do to save some time? You multiply by the what? Reciprocal of an right here. That's the same as dividing by a fraction. So what's the reciprocal of an then? Isn't that going to be what? 2n factorial. So it looks like this is 2n factorial as a numerator. Right? And negative 1 to the n, x to the 2n. So double check. So what do you guys think you want to do here in this problem? Right? Isn't this negative 1 to the n times negative 1? Aren't you going to do algebra here? And what about this algebra? What's that going to be? The x to the 2n times x squared. Properties of what? Right, from beginning algebra, and you get 2n factorial over, now I'm going to put this here, negative 1 to the n, x to the 2n here. But what happens down here? What do you guys think happens there? Anyone know? What do you think is going to happen there? What's the definition of factorial? Right? What do we just get through? Say, start with the number 2n plus 2 and subtract 1. Count backwards. You're going to now have what? 2n plus 1. And then you're going to have what? Could I say 2n factorial? So I don't have to count backwards forever? So why do I want to stop at 2n factorial? Cancel out right here. Is that right? So then the rest is like some nice cancellation. Negative 1 to the n. I got an x to the 2n. And I think that's pretty much it, because what's left now is negative 1 x squared and then these terms here. Now, again, by properties of what? Absolute value here. We could take the absolute value of a quotient, absolute value of a product. We're really taking the absolute value of every term, right? And what's the absolute value of negative 1? That's going to be what? Positive 1. And then you say, well, what's the absolute value of 2n plus 2? Well, I can just say that's 2n plus 2, right? Maybe I want to use my purple if I'm using some past, I don't know, algebra. This is 1. Definition of absolute value, because we're talking natural numbers now, okay? The only thing you probably are going to remark about is, what do you do with this x squared here, right? Say, what happens with this, algebraically speaking, right? Well, by the product rule, you simply pull out the power, right? So altogether, you have that absolute value x squared essentially over 2n plus 2, 2n plus 1. Okay, so we're just using those algebra properties now. You'd have to take the limit as n goes to infinity, an plus 1 over an. And you don't forget, you have this absolute value of x to the second power over the 2n plus 2, 2n plus 1. This is as n goes to infinity. Now, again, you got a nice constant here, because the limit is about what? N. So I can pull out, again, the absolute value of x squared times the limit n goes to infinity. That'll be 1 over 2n plus 2 to n plus 1. So what does this limit here go to? Right? You guys took Calculus 1. What is this? 0. Is that true? Okay, now this is 0 for all what? For all x values. Is that true? So you say, what are you talking about? It doesn't matter what x is. That limit's still going to be what? 0. Is that true? So if you say, what if x is equal to 0? Well, that limit is 0. What if x is not 0? Well, that limit's still 0. So this limit is 0, which is smaller than 1. And what does any limit that's finite smaller than 1 by the ratio test mean? Right? So this whole thing equals what? Is what I'm saying. This is 0, which is less than 1 for every x value. What does that mean by the ratio test? What does that mean? That means the series what? Converges by the ratio test. So if it converges by the ratio test for all x, what do they mean by all x? That's every what? Every real number. And sometimes you see that this way. All real numbers. Okay, in interval notation. So what we've seen is the examples where all three situations, right? We've seen where the answer is an interval. We've seen where the answer is a what? This is our conclusion here. Let's go back. We've seen power series converge now for all of these what? Situations. Those are all the different types of answers that you can get for power series convergence. All right, let's take a look at some more examples here. Let's see, did we do one that looks, do we do this? How about this? X to the n over 5n, n to the fifth power. So which test you guys think you're going to use, ratio or root test? Ratio or root? Here's our AN. You're going to use again what? Use ratio test. Okay, why not root test? You have to have a pure nth root for all terms. So if you don't, it's going to be the ratio test. So you're going to use ratio test. Okay. So in that case, if you said, you know, Mr. Judge, how do I get faster with these? Well, you practice number 1. Number 2, what you can do is just start up from the beginning, am plus 1. So you say this is x to the n plus 1 now. Change the term to not n, but m plus 1. And then multiply by that reciprocal of an, which would now be what? 5 to the n, n to the fifth power, x to the n. Okay, this is what you can do to get what? Faster. Now, by the algebra, beginning algebra, x to the n times x, 5 to the n, n to the fifth power, 5 to the n times 5, n plus 1 to the fifth power, that's x to the n. So when you cancel, you go, oh, I get rid of my x to the n's. I get rid of my what? 5 to the n's. And it looks like that's it. You might want to go back and see what's here. X, n to the fifth power, 5, n plus 1 to the fifth power. So what do you think you're going to end up with now if you use those properties again? Right? Properties of absolute value. Don't you get the absolute value of x n to the fifth power over 5 n plus 1 to the fifth power? Because all of these terms here are what? Are positive. You just don't know about the x value. So that's why you have to keep the absolute value. Right? So double check. Isn't that a lot quicker? That's a little bit quicker. Is that right? So now when you say, I have to take this limit, what do? Right? You now have n to the fifth power, n plus 1 to the fifth power. This is a limit for n. So what's the only thing that comes out as a constant? Just the what? Absolute value. And actually 5, I apologize. So you can take those constants out. You think of that as a constant because the limit is about n going to infinity. So this is n to the fifth power over n plus 1 to the fifth power. So where does this limit go? Does anybody know? That goes to what? That goes to 1, isn't it? Right? Isn't that go to 1? You can say, how do I know? Calculus 1. Calculus 1 or even what? Calculus 2, Lapido's rule. This limit's 1, is that right? Okay, so that means we have the absolute value of x over 5 times 1. This needs to be smaller than 1 in order to have our what? Convergence. Is that right? So what that means is you have this equation, or sorry, inequality. It's an absolute value inequality. Multiply both sides by 5. And then what's this the definition of? Isn't that the definition of x being between negative 5 and positive 5? Right? All right. So what do we do with this now? What do you guys think? What do we see on Thursday? What now? What do we have to check? Right? Because remember, what did you guys use? You used the ratio test. So by the ratio test, you had the limit of the absolute value of the ratios. If that equals 1, what does that mean? The test is what? Inconclusive. So you say, well, what does that mean then? Well, this is when you have convergence. And I'll leave that here. But what happens if the absolute value of x equals 1? So the absolute value of x is 5. That means x is plus or minus 5. Is that true? Positive 5, negative 5. These are the endpoints you guys have to check. So you might say, what do I check? I check when x is 5. I also check when x is what? Negative 5. So you say, what do I mean? What do I check? You got to go back to the original series. Okay, so this is how you check your endpoints. Plug those in. One to infinity, this is 5 to the n over 5 to the n to the 5th power. Over here, I have what? 1 to infinity, negative 5 to the n, 5 to the n to the 5th power. So again, just using algebra, what do you end up with? You have to know, what is this? What is that going to be? Well, what kind of p-series? It's a convergent p-series. So we know this thing converges. It's a convergent p-series. So in other words, that happened when x is 5. So we go back and we include that value for our interval of convergence. Now, what about over here? What does this give us? Do you guys know about the algebra over here? Isn't this going to be, right? Let me look at that numerator, algebraically speaking, right? Let's look at some algebra. That's negative 1 to the 5th power times n, which is negative 1 to the n, 5 to the n. Okay, so let's ask you guys this question here. What is this? What about that series? Let's say you had your test today. What would you guys say? What is it? What do you guys know about this one? See, this is what I'm saying. If you had your test today and they gave you this, what would you say? Doesn't this converge? How do you know that converges? Anybody know? What do you have to say? Don't guess. You can't guess. I'll mark it wrong. I guarantee you it'll be wrong. You have to give the right justification. What is it? By what? Alternating series test. Is that true? Does that converge by the alternating series test? Oh, we should have had the in-class test today. Nice. I should never have done the traveling I did. See who the true believers are. Ooh. Man, I regret doing that traveling. I want to find out who knows alternating series test, right? So what does that mean? When x is negative 5, what do we know? We include this. Our interval of convergence is going to be what now? Right? They're going to want to know that interval. Isn't that from negative 5 to positive 5? You're including those values. So there's your answer. This is your interval of convergence, ladies and gentlemen. Yes.
Would it be wrong to us, or would it be wrong for us to assume that we're going to utilize AST if we end up with the negative 1 to the n power?
Say that again?
Would we be wrong to assume that we're looking or we're using AST, alternating series test, if we see a negative 1?
Well, if you see an alternating series, I would suggest you use alternating series test. Does that kind of make some sense? I don't know. If you see an alternating series, I would plug it into the alternating series test criteria. Is that right? Right? Did you guys do homework on? If I check your homework and you did everything, because remember, what do people do? They copy from the book, or they copy from a solution manual and they turn it in, and their homework is like perfect. Perfect. And then they take a test, they can't do it. You could give them the same questions. Can't do it. You're like, how come you did it on your homework but not here? Like, ran out of time. You guys know what I'm talking about? Mr. Judge wasn't born yesterday, trust me. He's been teaching calculus for over 25 years. He's seen it all. Trust me on that one. Trust me. You ain't gonna get it over me. You guys know what I mean? He's in it 25 years. Oh, yeah. All right. So there you guys go. You should know that, right? What if you had your test today? What about this example here? We'll give you guys a very, well, it's not very simple, but, well, it is kind of simple. What if they give you guys this one? We've seen this last time. I can't remember. Did we put -2? We actually seen this last time. What do you guys use on this one? What do you guys use? You want to recognize what this is. How do you recognize it? Because you did the homework. What do you guys use? Which one? The root test? Use the what? It's a geometric series. How do you know it was on the what? That was on the homework. Do you guys remember the homework? It's a geometric series. Is that right? What was R? It's x minus 2. When does a geometric series converge? When the absolute value of R, which is the absolute value of x minus 2, is less than 1. This is what you have convergence. So you may say to me, how do I know these things? Because you spent time on the homework. If you didn't and you copied from a solution manual, right? Then you didn't spend time on the homework. You spent time copying from a solution manual. And then that's going to hurt on your final. It's going to be painful. So what do you guys do with this part right here? What do you guys know? Yeah, what does that mean again? Do you guys remember? It means what? -1 less than x minus 2 less than +1. So you want to add 2 now to the middle, the right, and the left. So here's the deal. 1 is less than x, which is less than 3. So this is going to be my interval of what? Of convergence from 1 to 3. Is that right? But let's see if you're really awake with this. Let's see if you're awake. Do I check the endpoints? Do we check when x is 1 or x is 3? Why not? Right, because the R will converge here, or we should say the geometric series converges only if the absolute value of R is less than 1. Only then. If it's 1 or if it's greater than 1, we got divergence. So you're strictly using the geometric series test. So we've seen that one, right? Okay, so then you're done. There's your interval of convergence. It's from I is going to be from what? 1 to 3. That's the interval. Okay, and then, ladies and gentlemen, you might say, let me see if you guys know what to do with this one here. Because we got x to the n over notch log n of n. And you can actually see it this way too. Maybe that's a tip off. Let me give you guys a big hint here. What do you guys think this would be? You're going to use the what? The root test. Yes. So that whole thing is going to be an, right? So you have the nth root of the absolute value of an. So this is the nth root, the absolute value, x to the n, natural log of n to the nth power here. So let's go over the algebra. So the algebra here is x over natural log of n. This is to the nth power. Absolute value. You guys remember this is product rule? So it's absolute value of x, natural log of n, product rule. This is the n there. And if you said, what if I have the nth root? Well, then that gets rid of my radical. So then this is the absolute value of x over the natural log of n. And by product rule again, you get the absolute value of x, absolute value natural log of n, and n is positive. So this is the absolute value of x over natural log of n. So that whole thing is what you're going to have to take that limit of. So the limit of that absolute value is the limit. I think I got to tighten this up. So what do you guys do with this? Bless you. What do you guys do with that? Don't you pull it out? Absolute value of x, limit, n goes to infinity, 1 over the natural log of n. What do you guys know about this limit now? This equals what? 0, which is less than 1. That's what you care about. That happens for what? That happens for all x? Right? So if it happens for all x, what's your, isn't that all real numbers? Interval of convergence is from negative infinity to infinity. Oh, let's try this one here. So we have negative 2 to the n over square root of n, x plus 3 to the n. So what test do you guys think you want to use here? Anybody have an idea? What should you use for this ratio test? Why not the root test? Yeah, you don't have n for every term. That power of n for every term. So, again, if you said, I'm worried about time, okay, here's what I would do. Okay, isn't that going to be negative 2 n plus 1 x plus 3 n plus 1 over square root of n plus 1? Okay, then multiply by the reciprocal, right? You say, what's the reciprocal? This is square root of n, negative 2 to the n, x plus 3 to the n. Okay, use some algebra. Negative 2 to the n times negative 2, x plus 3 to the n, x plus 3 square root of n. square root of n plus 1, negative 2 to the n, and this is x plus 3 to the what? Nth power here. So at this point, I would say you do what? Cancel, cancel, and then what is left here, it looks like these terms are left. Absolute value negative 2, x plus 3 square root of n over square root of n plus 1. Now, I want to remind you guys that the variable here is what you leave under the radical, this x plus 3. Everything else is going to come out because, well, if you take the absolute value of 2, that'll be 2 square root of n plus 1, because these terms here, these are positive here. Okay, n's a nice what? Natural number, so they're positive. The only thing that's going to be left with it in an absolute value is this x plus 3. So now, as you take the limit of that ratio, you say this is 2 square root of n remember what comes out as a constant. The number 2 comes out. Absolute value of x plus 3 comes out. So you have 2. Absolute value of x plus 3. Those are constants. Limit. And then you want to determine what happens with this limit over here. You guys know where that limit goes to? I think that limit goes to 1. Is that true? So you get 2. Absolute value of x plus 3 has to be less than 1 for convergence. But we need an interval. So remember, this is not less than 1/2. And now we can say what? Negative 1/2 is less than x plus 3, which is less than what? Positive 1/2, right? So do your arithmetic, solve for x. I think this is negative 7/2 less than x. I think that's negative what? 5/2. Is that true? Double check my arithmetic for these endpoints here. I think I'm okay. Negative 6/2, that's a negative 5/2, and then negative 7. So don't forget, though, what kind of test is this? The ratio test. So if it's the ratio test, we got to check the endpoints, right? We got to check when x is negative what? 7/2. And when x is negative 5/2, we got to check this here. Right? So you're going to have to plug in for x for each of these. And what do you end up getting if you do that? What happens to your series, right? You get negative 2 to the n. So you get negative 7/2. Isn't that negative 1/2 to the n when I plug that in? Double check. And negative 5/2, that's going to be 1/2. So this is negative 2 to the n, 1/2 to the n over square root of n. Double check my arithmetic, ladies and gentlemen. And I think this is going to be, what happens with this? Isn't this 1? And this is going to be negative 1 to the n. Is that right? Let me do this. Okay, you guys okay with this here? Now, why did I write this as 1/2 here and not the other one? What do you guys know about this particular series here on the left here? What is this? Yeah. This is a divergent what? Divergent P series. That's what you guys want to know. So we don't include that -7/2, okay? So this is not included. And then what do you guys know about this one? This is converges. How do you guys know that converges? By what? What's the test? The alternating series test. Do you guys remember what that test is? This is an alternating series, but the 1/square root of n, isn't that decreasing? That limit goes to 0? You know, that's the deal. So you include -5/2 as an endpoint. Where do I find it? Oh, here. So here's the deal. You include this here. So you might say, what in the world does this all mean? Well, this is what it means. Right? Your interval of convergence is an open endpoint at -7/2, but it's a closed endpoint at -5/2. So, you know, that's what they're looking for here. Anyway, I wish I had, what do I wish I had here? I wish we were broadcasting online, because I do have more examples of what? Power series. Okay, I can show you guys this. Well, let me see. Is it